H and S was the other things.
Which one do you read? The vapor?
It's a saturated liquid, so you read the liquid.
Oh, the liquid? Okay.
So it's a saturated liquid. I also need H. Here, what units did you use?
Joules per mole.
Joules per mole.
You also have different reference states. You don't have
Yeah, the reference states.
We'll write it in white. I don't know if they can tell the difference, but like the other one. Okay, I'm going to write it down here. What?
Okay,
now,
so
I'll put here pure fluids for P. And that way, so you're comparing the two.
my H is 4136.8
Okay.
joules per mole.
Okay.
Okay, and you also needed S, right?
You don't need it, but you don't need S.
Okay, if you don't need S, then okay. So what was the what did we go to next part?
You're going through a throttle.
Okay, so we were doing constant H.
Yeah.
And what do we know about this guy?
You don't know anything.
No, we got P from the third.
You know,
We then went to the third
All
one.
you can do is write the H
something
and you
else.
go to the next step.
We know the H here. We don't know anything else, so let's skip that for now.
You go to 3.
This guy is 278 Kelvin, and he's a saturated vapor.
Right.
Is that,
So,
do you have a question?
I said my H wasn't there. I think I probably did something wrong.
No.
You probably
Change
either
the
have a
units.
different reference state or
The units?
did you not have H at all, or just a different?
Did you make it?
It's a different number.
Yeah. What's your units on H?
Joules per kilogram.
Yeah, mine's
Yeah.
joules per mole. So
There you
that's
go. Thank you.
where it is. Yeah. Yeah, if you want to change units, guys, you can just, like up here in the report, you can change what the units to whatever you want, which is quite nice, actually.
Yeah, you got a question?
When I hit calculate, it won't let me get to the next.
What? Say it again?
Click on report.
Click on report, yeah. Report. On the top row, it's like the third or fourth one over. It's a little yellow notepad. Okay, so the next thing we did was,
Are you able to get it?
Yeah.
you got it? Okay. Next thing we did was saturated vapor at 278 Kelvin. So we know it's saturated, so we're going to go back to our saturation curve again. It's 278 Kelvin. Okay, so I've just changed the T to 278 Kelvin. Nothing other than that. I'm going to click Add New Saturation Table, Calculate, and Report. And that report tells me, and this one's a saturated vapor, right?
Yep.
This report tells me my P now in bar is this.
0.008?
0.00863.
Not bad. Yeah.
Yeah, that's really good off the plot, yeah.
Yes, 0.0086.
Yeah, 86.
You know me.
0.00863. What else do we want here? H and S?
98 and S.
Okay. H here is going to be, we're at vapor, right?
Yep.
Okay, so H is 45214.5.
Okay.
Okay. And S is.
I think you ate at 1.
Sorry?
I think you ate at 1.
45214. Yeah.
45214.5. Yeah. And S is 162.7. Okay, so now we did going 3 to 4, right?
Yeah. Now you have 4. Now you know all your
3 is constant. 3 to 4 is constant entropy, right?
Yeah.
And we know
P
that
is-
R.
Yes.
P
You know P
okay.
equals P1.
Okay.
So.
And this thing is not saturated.
Right. It's superheated vapor.
This is superheated vapor. Okay, so now we're going to go back to list. Since we're not saturated, we can't use the saturation tab. And we know that this guy is at 0.15 bar is the pressure. So we're going to put our pressure at 0.15. We know it's the same entropy as, we know it's 162.7, what we found before. Unfortunately, pure fluids isn't that magnificent, so we can't add an entropy, so we have to do T, and we have to do it iteratively the same way as the book program does it. So I'll actually try to use the same guess as Chase used. So 400 was the first guess in Kelvin. So I got 400 Kelvin, P equals 0.15 bar.
Kevin, you got a question?
Yeah, you got
Yeah.
a question.
Couldn't you plot the entropy for the features of
Probably. I don't know how to do it. I know this way works.
Unicat, can you plot entropy versus temperature? I
there's
guess you could.
There's probably a way to do it on this.
Probably.
If you want to plot,
Plot,
you can set
yeah.
up an isoplot, and you can,
Have you tried it?
Oh, you gotta do
yeah.
it.
And
Yeah,
it
so
works?
you-
Okay, could you give me a guess of the temperature that you got from it?
Oh, I didn't do it for this problem, I did it for
Okay, can you just,
Okay.
got it.
That, yeah, you can do that on the plot tab. I'm
Uh-huh.
gonna do it this way because I plot tab.
Got it, I understand. So,
Um,
what we're told from the floor is that you can do it two ways. You can plot S versus T in interplate, or you can do what Kevin's doing, make a guess on the temperature. It's gonna be higher. It's superheated vapor.
Yeah.
So it's gonna be higher than what was going into the compressor. So 400 degrees, 500 degrees,
Yeah.
550, and you'll get there.
Okay, so once we've added these conditions, I'll click Add New Conditions, calculate, and then go back to my report. And up here at the top is what I've just calculated. And if I look at the S, I've got 151.21. So what was I?
162.
162. So I'm not high enough yet. So 500 or 400 is not high enough. Okay, so then I need to go back to my list. I'll go up to 500. Add that condition, calculate that. When I go to my report, S is, now here, you have to be careful that you read the one that you just put in. So it's gonna organize it based on the temperature, I think, so just be careful there. S is 158.98, so I'm getting there, but I'm still not there yet. So let me go to, I believe 540 was what we ended up with last time, so add that. Calculate and report. And if I go to 550 Kelvin, I'll see S is 161.7. So that's pretty close. That's close enough to call it. There. So now I can read off the H that I have here. My H is 54236.7.
54236. Yeah. 54236. Sorry, say-
54236.7.
Okay.
Okay, so that's my H. So did we need any more information here?
You want to take the difference of the H3
Yeah.
and H4?
What's H3 and H2?
Uh, 54736.7 minus 45214.5.
That's one of the numbers, now I need the other difference.
What number did you get for
3 and 2. That gave me 9522.
And was that what you got before?
I needed to, that's a ratio.
Oh, I see. Now you need H3 minus
H2.
H2, 45214.5. Subtract from it 4136.8.
Got 4.31. So I got 4.7, you got 4.3.
Yeah, so we're pretty close. Chase read his off a graph, so there's going to be a little bit of error in there.
Plus it's a different equation state.
But yeah, it's a different equation state too. But you can see you're going to get the same thing from using proof.
Within 5 to 10%. That's
Yeah.
an engineer you
You
can't
got
expect.
4.7 versus.
Does anybody have questions with how to operate that? It's pretty straightforward program.
Yeah. Oh, sure. I know, I'm very transparent.
What was the final time you used?
Yeah, we have a question.
Final temperature was 540.
540 was a guess. If you guess 550,
You'll probably be pretty close to
you're
it.
pretty close. It seems to slow very, very slowly with temperature. One here and then one there. Yeah, go ahead.
What is the percent area you give us on the test?
Oh.
How close
Well,
do you need to be?
If you're within 10-15%, I'll be happy. Okay, I mean, just don't be 100% off. Yeah, I know. And you need to know what you're doing. If it's, I mean, you need to tell me whether you're holding the entropy constant or holding the enthalpy constant, or is the pressure constant. That's up to you.
Most of the grades are going to come from the
Yeah,
process.
so in other words, if you got a pressure of 0.0085 and she got a pressure of 0.0092 and you held the pressure constant, she held the constant, that's fine, then you're both to be accepted. But if one of you just said, no, that you're doing something, which is, that you can't justify, then it's a question. Yes, sir.
What are the units for enthalpy and entropy?
In this case, it was joules per mole.
Joules per mole and joules per mole Kelvin.
But you could use it joules per kilogram if you wanted. It doesn't matter. But just be consistent. Just be
if you're consistent.
And in the end, report it the way it's asked to be reported, okay? If the report says we want the energy per time, kilojoules per second or kilojoules per minute, report it in those units, okay? Yeah, yes, sir.
Back to my original question, can we find the mix in part 2 of the percent liquid, percent vapor?
If you wish to.
I was asking if we could do it right
Can I
now.
actually do it?
Yeah.
Let's try. I don't know if we can, but let's see. Part 2, which is exit, you mean, path 2.
Yes.
So we know the H is this, we know the pressure's here, we have the temperature.
You
Yeah.
need the temperature.
Would you use the graph of P versus T to find the temperature?
What, would you care about the temperature or do you care about the mix?
The
Well,
mix, but
okay.
I don't think we can
Okay.
actually get the mix.
Well,
The
if you
problem
want.
is you have to get, what is the HV and HL?
Yeah, so we
To
have
get
to-
that, you have to have a temperature, you have to put it in T and P.
But if it's saturated,
It's not, this is a mixture.
yeah, but if it's a mix, doesn't the phase rule tell you that you need only one intensive variable, the pressure is given? So it should be specified. I have one component, 2 phases, right?
Right.
And
you
so
can
I
go
need
back
only
out.
one intensive variable to
Right.
specify it. I specified it, it's called pressure.
Right,
So
so you
we
should be able
have
to
to
get
be-
the temperature back out.
We don't need to, temperature's an output, we don't care what it is, okay?
Right, well, I was saying to get the HV and HL off the
Yeah.
program,
Right.
that's the temperature, which you can get off, yeah, so you get the temperature probably off the graph at the
Do
saturation.
you want the temperature or do you want the mix?
I don't know how to get the mix if I get the temperature first. I like
Because the
those.
problem is, to get the mixture, we need HV and HL.
I
The
agree,
way the
but I
program
don't know, what
works.
do you want, okay?
I want the mix, but I didn't know how to do it if I get temperature first.
Yeah, he wants the mixture.
Okay, if you want the
I want
mixture.
the mixture.
Okay,
So,
you don't need to know the temperature, you can get it
Don't
as
need to.
as an extra
You
byproduct.
shouldn't have to, yeah.
You didn't have to.
HL and H2, that's what we need, but to get HV and HL, you need T and P.
Only P. Because it's 2-phase. It should automatically give you HV and HL.
That's
program
not
doesn't
true,
give you
that's
that.
not
Really?
true with the
No,
program.
can't you
Program-
tell the,
you
can't
I'm
you
on
give it
PC
just
too,
pressure
so
and
it's
set
not
out.
as-
okay,
can't.
can't you tell the program you want it at the saturation for that
Yeah,
pressure?
but if you
Not
tell
on-
you're at the
not on
saturation,
PC.
then
Huh?
Not on PC.
you can't do it on, you can tell it on mine that
Oh,
you're at the
okay,
saturation.
okay, so it's the difference between the so.
Yeah.
Right, on PC, you have to find the temperature, which means you have to go to the graph, get the temperature back out, and then find these two.
I see.
Yeah, if it knows, yeah. The way that you tell the PC that you're at the saturation is you have to read it off the graph.
I see.
The PC doesn't have a
Got it.
I'm at saturation
Got
button,
it, got it.
where mine does.
Does that make sense?
Yeah.
Okay,
But would anything change finding the temperature? You just plug in the pressure and find the.
Go down to the temperature. You
Okay.
go to the line, go
Then
down to the
I should
temperature.
have gotten it right. Okay.
Yeah, and then you see what temperature, pressure, get what that HV and HL is at that, and then calculate it back out.
Can
Okay.
you do it?
Hmm?
Can you do it?
Can I do what?
Can you try it?
You
And
do it
then we'll
really-
read your numbers.
I don't know how to do it.
Okay, what, no.
Go to
What-
saturation and tell it you're at point whatever bar.
You're at .009 bar,
Go to the saturation tab.
and then tell me what
click that.
HV and HL are.
You have a Mac or you have
He has Mac, it's easy, because he can just do saturation, you don't even have to find it.
So you're using Pure Fluids one?
Yeah.
Okay, so you're using Pure Fluids. Why don't you go to Pure Fluids? In your case, he's
What-
got an easier situation.
What temperature do I use?
You don't have to give it.
Can you,
You
look,
can give
look,
it pressure.
let's say it again. If you're using Pure Fluids, if you're using Pure, look,
.0086, whatever you use.
this is a 2-phase system. Theoretically speaking, you need only 1 degree of freedom. You have only 1 degree of freedom. If you use Pure Fluids, it is enough to give the pressure. Everything else is an output, provided it's in the 2-phase. If you're using the PC can only draw the graph of the saturation line. That means you've got to give a temperature range and a pressure range to draw that graph. When you draw the graph, according to that pressure, you read the temperature, and you go back and you determine from that pressure and temperature at saturation what HV and HL are. Okay? There's an extra step needed if you're using the PC.
You have to find it.
There's a shortcut if you're using the Mac.
So for here,
So,
right?
yeah, now we're gonna look here. Now I've given it a pressure of .0086 bar at saturation. So now it'll tell me the properties for liquid and vapor at that saturation, it'll tell me the T. That T is what you would have had to read off the graph in the
Yeah.
PC version, and then you would have had to plug that T and the same P back in
To
to
read
get
HV
this
and
stuff.
HL.
I got 282 for mine, so it's pretty close.
Yeah, you got 282. Yeah, that's.
When you read it off the graph.
You read it off. Yeah, that's close. So now I've got H. On the very left, you got L and V. So the top one is L. So HL is that. HV is that. And then you can use the.
Do you see how to do this? Clear?
No, I have. Well, I don't know why you put it. Like, where did you get 277.94?
I didn't specify that as an
He's
output.
just
It's
putting in
an
pressure.
output.
It's
I-
saturated.
Let's
Oh.
go back to the tab.
Yeah, I'm in such.
This thing's
Let's
smart
go
enough
the
to read the
saturation
graph
tab.
for you.
All I've told it is I'm at P of 0.0.
Oh, I was using the top thing. Got it.
It will. This thing's smart. It can read the graph for you.
Yeah.
PC doesn't read the graph for
Actually,
you.
just-
As long as you specify it's saturated, it'll read it.
Okay, got it.
Okay?
If you want to read it yourself.
Yes.
The graph works out to around 540 as well.
What's that, sir?
Plotting it works out to about 540 as well.
Nice. For this one. the
Oh,
entropy
okay.
thing?
You're going back to that. Good.
Yeah,
Thank
that-
you.
That's also a valid way to do it.
That's good. Quick question. Yes, somebody had a question? Somebody raised half a hand, quarter. Slowly. Is it clear? I really want to make sure everybody's comfortable, okay? I've given a lot of homework out. I really want you to try. Most of the problems are, look, this is a fairly complicated problem. It had in it a throttle, it had in it a heat exchanger, and it has in it a compressor. You can't really think of too many problems much more than this. The other type of problem is the explosion problem. That's about the other type. I mean, how many? I can tell you I can't dream up with too many problems. This is one, and the other is the explosion type. So if you really have understood how to work these, I'd like to see everybody score 100% on this, okay? Yeah.
Could you real quickly go over what the process was for each transition, like isentropic?
Okay, look, okay, why don't you go there?
I got it real quick. So I wrote it down to be sure I didn't mess up when I said this.
I don't think you did.
All right. So problem one, or for point one, we're going through. I think this is an expansion valve.
Right.
So throttle valve. So we know 1 to 2 is isenthalpic. Okay, so this is delta H is 0 here. Okay, we know that for the
Evaporator.
evaporator, it's 2 to 3. We said that it was,
Delta P is 0?
yeah, delta P was 0.
Right. I mean, in actuality, delta P is not 0, but you don't know, you can't put in enough fluid mechanics inside this to decide how much frictional loss you have and therefore how much pressure drop you would have had. You need to know something about the heat exchanger, et cetera. So given the fact that you don't have any of that, pretend the delta P's
All we're
negligible.
doing here is we're just basically assuming that we're putting in just enough energy to change the state. So we have vapor liquid mix, which is saturated technically. We want to push it just all the vapor. So we don't change the pressure very much, if at all. Right. 3 to 4, this is the delta S is 0.
And that's assuming 100% efficient?
Yeah, perfectly efficient compressor. And then same thing with condenser is just the reverse of an evaporator, so same thing, delta P.
Okay, thank you.
Is that clear?
Now we can change this out from like a turbine instead of an expansion valve, and change the problem.
Yeah.
Got a Rankine cycle instead of.
I mean, you might imagine that this is a home, you could have a home refrigerator like this, but if you're doing an industrial process, why would you throttle it and not get anything out of it? I mean, throttling is just an expansion.
Right.
If you can get some work out of it, you would have put a turbine there instead, right? I mean, that's, you would say, I'm trying to, it all depends, of course, then there's a cost ratio. How expensive it is to have a turbine versus just having it out. So there are other factors that engineers have to worry about, okay? Is that clear? Anybody, any questions? I want to make sure you really got it. Give me just 1 second. Okay. Thursday, there will be no class, as I pointed out. But if you have any questions only on using the PC, because Chase does not have pure fluids. Any of you PC, any of the PC people, pure fluids people can come in too. It's
Yeah,
not-
I know how fluid works. I can't
exactly,
show you, but
exactly.
if you bring your laptop, I can show
Exactly.
you.
Yeah, he can't bring it up his machine, but if you bring your machine, he can tell you. If you have questions on any of the homework that's there, please, Chase, and then we'll put out the solution.
I don't have the chapter 6.
I will send that.
So he can be.
Yeah,